ringland or something?
Yeah. 80% on one.
Oh, it's all coming out of there. Hold on, do that again. Look at the amount of leakage.
We'll put the cap on for a second. I just capped this. Yeah, put the cap on.
To read it?
Yeah. Oh yeah.
The flow?
Probably tear it apart to see what it is.
Well, what do you think, Brian?
Think we should take it apart? Both of them.
Both of them? Hey guys, Pablo from Real Street Performance, and today we wanted to bring you along on this assembly for a K24 turbocharged engine build. Today I'm going to be walking you through the assembly process, go over some of the parts that we selected for this engine, and tell you exactly why we went with these parts instead of going with OEM components. In one of our previous engine dyno videos, you may have noticed that the K24 on the engine dyno was a completely stock, unopened long block. With the turbo testing that we were doing, we started running the engine around that 500 horsepower range to get some testing done with different intake manifolds. Immediately, we noticed that there was an excess amount of leak down past all 4 cylinders, and after running it a little bit on the engine dyno, the leak down remained in cylinder 4. We noticed this when the engine dyno started behaving differently. You would see variances in EGTs, fuel trims were having to change to have the engine run, and it started to sound differently as well. We immediately began to think that there might be a problem with one of the pistons, given that this is an older engine. On the engine dyno, we were able to pull a cylinder head off and take a closer look, and upon further inspection, we saw that cylinder 1 had broken the ringlands in a couple different spots. That led us to then continue taking the whole engine off of the engine dyno. Once we disassembled the engine, we took a little bit of a closer look at the other cylinders as well. 2 and 3 were behaving pretty nice on the engine dyno. We could see that the leak down was at a minimum, but cylinder 4 was a bit questionable. And then you could see the piston rings were actually seized onto the piston itself. This is likely due to having sat in a container when it was coming from Japan over here to the US, and things tend to corrode, especially in the sea air and a lot of humidity. Luckily, it was only isolated to that slug, and we were able to quickly determine that that was the problem, and now we had an idea of what we needed to rectify moving forward. Given that we already had a couple issues between the seized piston rings, the ringland failure in cylinder 1, and a whole bunch of things that we wanted to push this engine harder, but we aren't going to be able to do with a stock component, we decided to upgrade to a couple of different things. For those upgrade components, we're going to be using the set of Weisico off-the-shelf pistons and some Skunk 2 H-beam rods along with the OEM crankshaft. These pistons are very similar to the OEM compression, as we wanted to replicate that type of build. Now, the reason that we stuck with these pistons in particular is because of their bore. This is an 87mm bore engine from the factory, and these are 87mm bore pistons. Now, we wanted to do kind of a build that you could replicate exactly at home without having to take the engine to the machine shop, because that's what a lot of you guys have been requesting. Some people like to throw some pistons in as long as the measurements are okay, and as long as we're able to replicate that perfect piston to wall clearance as well as the other clearances we're targeting, that's okay for this kind of build. We went ahead and measured these out-of-the-box Weisico pistons. We were very happy with how consistent they were around the board, and we then checked the bore of the engine to make sure that the piston to wall clearance would be okay and that we'd be close to the target that we're aiming for after honing the engine. For the engine hone, we wanted to get a nice crosshatch as well as deglaze the cylinders so you could have a fresh seal of the piston rings to the engine and still be within the right tolerances that we were targeting. And after deglazing the OEM sleeves, we did achieve that piston to wall clearance of 3.5 thousandths with the proper crosshatching to pair with those brand new piston rings. For the crankshaft, this is the OEM 99mm crankshaft that came out of this K24. We cleaned it up, checked the journals, everything was within spec. Paired along with the OEM cleaned up crankshaft, we're doing an off-the-shelf set of King race coated bearings, and that's going to be for the mains and the rods as well. For sealing the engine, we'll be using a 0.1 head stud along with an OEM head gasket, and then some OEM valve cover gaskets as well. For the cylinder head, we approached it a little bit simpler as we wanted to do some camshaft testing in the future. We're only going to be doing some springs and retainers by Supertech to have that upgraded spring pressure, make sure that we're nice and safe during boost, and in the future we can do that camshaft testing that we're talking about and be able to give you guys some back-to-back data with the stock cams, different stages, or different types. For that, we want to rely on you guys, so please let us know in the comment section down below what you'd like to see. It's important to note the orientation of these rings. Depending on the manufacturer, you'll always refer back to their guidelines. But in this case, Weisico does let us know that their rings are marked specifically with a top and bottom position for the top and secondary ring. There'll be either a dot or an N on the top etched in on the piston ring itself. Also, caps on these rods and other things of that nature are not interchangeable. So both sides right here you can see are etched with 1. That's so you know which rod belongs to which cap. What we're going to do now is start preparing the block to receive the pistons and rods. We'll go ahead and get started on clocking these piston rings. Each one of the manufacturer's guidelines refer to how they want their piston rings clocked. Then in this case, we're going to be using a piston ring tapered compressor, which is this one right here. Weisico makes a really nice unit, and since we're using Weisico pistons today, it's fitting that we stick with Weisico. So you want to add a little bit of oil here on the skirt of the piston, as well as on this tool right here. Add a little bit of oil onto the bore as well. If you look down, currently the journal for the crankshaft is in its up position for that cylinder. We're going to rotate it down and out of the way. That way when the rod goes down, it doesn't jam into the journal or anything. Assembly loop here on the bottom. We'll do the same later on the cap end of the rod. And in one sweeping motion downwards, easy install. It's good. Another crucial upgrade for K24, especially when you're going higher horsepower, is the oiling system. So here we have a 4-piston ported Type S oil pump, and this is actually their kit version of the unit, and it includes the windage tray, the oil pump chain, as well as some different hardware that you'll need for this taller oil pump. What you will be reusing from your factory components is the OEM sprocket. That doesn't change between any of this. You'll also be using the bottom tensioner. In this case, we're going to be using a new tensioner from Honda, and we'll also be upgrading to another component on the bottom of the chain, which is the drag cartel lower timing chain guide. Since we'll be doing a lot of testing, especially on the engine dyno, different camshafts, maybe different cylinder heads, and a couple different things that might require the timing to come undone, this guide will allow you to have the retention of your tooth location onto that sprocket, so you can really make the whole process a lot easier. In some cases, you don't even have to take the side cover off if you're only doing the camshaft changes. So we'll be installing this. There are a couple things that you need to look out for. On the bottom of a K24 engine, you do have this little plug which has an O-ring on the outside of it. An easy way that I like to remove these is just knock a wood screw in there. You give it a little turn so it starts to get embedded onto the top of that, since it has a dimple there from the factory, and you'll just pull this out. And that plug location, in most cases, is already threaded to an M8 thread. And that's a typical Honda bolt that you can normally have in your toolbox. You'll seal that up with some RTV. Now, in the case that you get a block that doesn't come threaded, you'll just tap and thread it after the fact. Obviously, you would do that before assembling. You don't want any of that metal shavings. It's just something to look for before you start assembling the engine itself. 4-piston does rate these to be roughly 25% more flow through the oil pump, and they already do come pre-notched to the K24 footprint. You guys might have seen some of the previous videos where we did the K24 camshaft testing, and to fit a Type S oil pump, we needed to notch this whole section, and you can see that 4-piston has already done that. So it makes it nice and easy to install. They've also tested it up to 12,000 RPM, which is way more than we plan to run this engine to, so we're more than happy to use it for this configuration. Also, to give a quick example, the bolt that we use right there is a standard Honda M8 12mm head bolt, and that fits perfectly with the clearance needed on that windage tray. I know it might seem like kind of overkill, but you want to double check that before you start assembling. Here for reference is another M8 bolt, but this is an aftermarket piece of hardware, and you can get this at Ace or Home Depot, Lowe's, things like that, but it won't fit within that area right there. And if you get it all sealed up and go after the fact to put your windage tray, you might be surprised to find you have to redo that. So double check things like that before you actually put silicone or sealants. You want to make sure that you're working with parts that will work, and you won't have to do things again in the end. For today's setup, we're actually going to be using a combination of OEM and aftermarket parts. We did get the cylinder head completely cleaned up and free of any debris or old oil sludge. For the aftermarket components, we're using this set of SuperTech valve train. These are their dual valve springs, as well as titanium retainers, and their aftermarket seat as well. Given we have a stronger bottom end now, we plan to do some aftermarket camshaft testing in the future with this engine, and having something that will be able to support that is key. Now that we have the cylinder head all prepped up, everything's installed there, we're gonna start unboxing our 0.1 head studs. And what I really like about this kit is that not only it includes fastener assembly lube, but very simple thing, it has a brush that also comes with it. Once we open this up, you can see that everything is individually packaged and vacuum sealed. It's really nice aesthetically, but more importantly, it also keeps the threads nice and happy so they're not jumping and hitting each other while it's being shipped. For those of you using these head studs for the first time or want to get more familiar with fasteners, it does include an install guide with step-by-step processes that you can follow at home, and it makes the installation a breeze. For the other supporting components that we'll be using on the cylinder head to block assembly, we have some OEM goodies. We have an original Honda head gasket right there, original Honda guides, not only for the sides, but the top as well, and a brand new Honda timing chain. When we did the block side of things, we already did install a new guide and oil pump timing chain as well, so everything all together will be nice, fresh, new units. The whole assembly for the OEM camshafts. There are some spots that you need to apply RTV down below, but we wanted to show you a quick little tip. If you are installing this whole thing as a unit, it makes it so much easier to just attach these rockers with a couple zip ties. That way they're not flopping downwards when you actually put this whole assembly onto the cylinder head. Once it's on there and you are about to start tightening everything down, you can cut them off and they go down to their location. But quick little tip right there, makes it a whole lot easier. Alright guys, we're all wrapped up on assembly for this video. We also did put on the turbo kit that was previously on the other K24 that we did here on the engine dyno, which is a very simple 6466 R-Tech manifold with the Skunk 2 intake manifold as well. Now this engine in particular was one that you guys wanted us to build, which will be a simple stage 1, if you will, K-series engine build. This one in particular we're going to be using in its maybe 500 or 600 horsepower range, but a lot of you have also been asking for a higher horsepower build. Once we continue doing some testing on this, maybe some camshaft swaps or things of that nature, we will eventually go into that higher horsepower range with the K-series, as we've done with the 2Js and the other engines that have been on our engine dyno. If you guys are interested in seeing more content like this, please consider shopping with us here at Real Street Performance. By you guys giving us your business, we're able to deliver more content to you and all help each other as a community learning things all together. As always, please leave us more recommendations down in the comment section. We love hearing your feedback as well as your suggestions for us to do stuff here in-house. And like always, thanks for watching.